In the last videos, we learned how to compose functions. In calculus, it's also important to be able to identify two functions that make up a given composite function. So today we are going to learn how to do the opposite of composing functions, called decomposing functions. Let's say we have the function h of x equals 2 over x minus 3 squared. How can we write this function as a composition of two functions? To decompose a composite function, we're going to look for an inner function and an outer function. One way to write h of x as a composition of two functions is to take the inner function to be g of x equals x minus 3 and the outer function to be f of x equals 2 over x squared. Then we can write h of x equals 2 over x minus 3 squared equals f of x minus 3 equals f of g of x. Let's validate that for the sake of practice to see if that's correct. So let's say f of x equals 2 over x squared and g of x equals x minus 3. Now, f composed with g is f of g of x, which means we are going to plug in g of x for x. So we get f of x minus 3, which is then 2 over x minus 3 squared. So we solved this problem properly. Let's look at another example for the sake of practice. How can we find the two functions f and g such that f composed with g equals h of x equals 2x plus 3 squared? I really encourage you to pause the video and try this on your own. Again, we are going to look at an inner function and at an outer function. One way to write h of x as a composition of two functions is to take the inner function to be g of x equals 2x plus 3 and the outer function f of x equals x squared. Then we can write h of x equals 2x plus 3 squared equals f of 2x plus 3 equals f of g of x. Let's validate that. F composed with g equals f of g of x equals f of 2x plus 3 equals 2x plus 3 squared. So we solved this problem properly. Note that sometimes when decomposing functions, there are many correct answers. More to come, so stay tuned.